Welcome back. You know I love building wild contraptions and steel is at the heart of almost everything I make. But steel isn't just one thing. It's more like a recipe, where tiny changes in ingredients create totally different results. Today we're diving into the secret world of alloying elements, the spices that turn plain iron into thousands of specialized steels. From skyscrapers to razor-sharp knives, each type of steel is tuned for a specific job. We'll break down what these elements do, making steel strong, rust-proof, or tough enough for freezing temps. This is the hidden science behind the modern world, and it's everywhere you look. Ready to unlock the secrets of steel? Let's get started. First up, the king of steel ingredients, carbon. Pure iron is soft. Imagine marbles in a box, sliding around easily. Add carbon, and it's like pouring sand between the marbles. Suddenly, everything's locked in place. That's what makes steel so much stronger than iron. But the amount of carbon is critical. Too little and steel is weak. Too much, and it's brittle. Low-carbon steel is ductile and easy to shape, perfect for car bodies and construction beams. High-carbon steel is hard and holds a sharp edge, ideal for tools and springs, but it's brittle. It's all about matching the carbon level to the job. The right balance gives us everything from bendable beams to razor-sharp blades. Carbon is the foundation of steel's strength. Every steel project starts with this crucial ingredient. Let's see what happens when we add more to the mix. Carbon gives us strength, but what about toughness? The ability to take a hit without breaking. Enter manganese, the unsung hero of steel. Manganese cleans up impurities and boosts toughness, making steel more reliable. In high amounts it creates Hadfield steel, which actually gets harder the more it's used, a property called work hardening. That's why it's used in railroad tracks and rock crushers, places where steel takes a beating. Every train wheel passing over manganese steel makes it tougher. It's also found in mining equipment and even prison bars. Manganese turns steel into a material that thrives under pressure. It's the secret to steel that doesn't just survive punishment, it gets stronger from it. Toughness and durability, all thanks to a little manganese. Now let's tackle steel's biggest enemy, rust. Rust is steel's nemesis, but chromium is its shield. Add over 10% chromium and you get stainless steel, protected by a thin, invisible layer of chromium oxide. This layer instantly reforms if scratched, sealing out rust like a self-healing armor. That's why your kitchen sink and cutlery stay shiny for years. Chromium's protection is crucial in surgical tools, chemical plants, and architecture. It's the reason stainless steel can handle water, acids, and weather without corroding. Whenever you see gleaming, rust-free steel, thank chromium for its invisible defense. It's the element that keeps steel looking new, year after year. With rust under control, let's see how we boost steel's strength even further. Next up, the micromanagers of steel. Need steel that's strong and wear-resistant even at high temperatures? Enter vanadium. Vanadium acts as a grain refiner, creating tiny, strong grains inside the steel. Think of it as building a wall with small bricks, much stronger than big blocks. It also forms vanadium carbides, microscopic particles that reinforce the steel. This combo boosts strength, hardness, and durability. Vanadium alloyed steels are used in drill bits, gears, and axles, parts that face heat and stress every day. Even a tiny amount of vanadium makes a huge difference. It's the secret sauce for high-performance, long-lasting steel. When you need steel that won't quit, vanadium is the key. But not every element in steel is helpful. Some are troublemakers. Not all elements in steel are invited. Sulfur is usually an unwelcome guest. Sulfur makes steel brittle, especially when hot, causing cracks during manufacturing. It forms weak spots that can lead to failure under stress. That's why metallurgists work hard to remove it. However, in rare cases, a little sulfur is added to make steel easier to machine. For most uses though, sulfur is the enemy of strength and toughness. Keeping sulfur low is crucial for reliable, high-quality steel. It's a reminder that even tiny impurities can have a big impact. Next, let's meet another troublemaker, phosphorus. Some elements just don't play nice in the steel mix. Phosphorus, like sulfur, sneaks in from raw materials and causes problems. Its main crime? Making steel brittle at low temperatures, a danger for bridges and ships in cold climates. Phosphorus weakens the bonds between steel's grains, making cracks spread easily. That's why strict limits are set for phosphorus in critical steels. Occasionally a tiny bit is used to boost strength in sheet steel, but it's rare. For most applications, phosphorus is an impurity to eliminate. Safety and reliability depend on keeping it out. Now let's get back to the elements that help steel shine. Silicon is a steelmaker's cleaner and strengthener. Its main job is to remove dissolved oxygen from molten steel, preventing weak spots and bubbles. Silicon grabs oxygen, forming slag that floats away, leaving cleaner, stronger steel. A small amount left in the steel boosts strength without sacrificing toughness. Silicon is found in structural steels everywhere, making them more dependable. It's a quiet hero, working behind the scenes. Clean steel is strong steel thanks to silicon. But what about steel that faces extreme heat? When steel faces extreme heat, molybdenum steps in. Molybdenum boosts steel's resistance to creep, slow deformation under high temperatures. It forms tough carbides that hold the steel's structure together, even when red hot. That's why it's used in power plants, refineries, and engine parts. Molybdenum keeps steel strong when the heat is on. It's essential for any steel that must perform under pressure and heat. High-temperature environments demand molybdenum's strength. Now let's see how tiny additions can make steel even tougher. Aluminium in minuscule amounts has a giant impact on steel's toughness. It's a master deoxidizer, cleaning up molten steel for a flawless finish. More importantly, aluminium refines the steel's grain structure, making it tougher, especially in the cold. Fine grains stop cracks in their tracks, absorbing energy and preventing failure. Aluminium-treated steels are used in ship hulls, pipelines, and storage tanks. Even a pinch of aluminium makes steel safer and more reliable. Sometimes the smallest ingredient makes the biggest difference. But what if steel needs to stay tough in the coldest places on Earth? Nickel is the element that keeps steel tough at freezing temperatures. It changes steel's structure so it stays ductile and strong, even in extreme cold. That's why nickel-alloyed steels are used for LNG tanks, cryogenic equipment, and even in space. Nickel also boosts corrosion resistance, making it a key part of many stainless steels. When steel needs to survive the coldest environments, nickel is essential. It's the winter coat for steel, keeping it safe when temperatures plunge. From Antarctica to outer space, nickel-alloyed steel delivers. Now let's look at a steel that uses rust as its own defense. Copper gives us weathering steel, designed to rust but in a good way. With copper, steel forms a stable, protective patina that seals out further corrosion. This patina is why bridges and sculptures made from weathering steel last for decades without paint. The famous Angel of the North sculpture is a perfect example. Copper turns rust from a problem into a solution. It's a clever twist in materials science, using nature's attack as protection. Weathering steel is both beautiful and durable thanks to copper. Now let's meet the mighty microalloys. Titanium, used in tiny amounts, packs a huge punch in steel. It refines grains and forms hard particles that boost strength and toughness. Titanium's particles block defects, making steel stronger and more durable. It's used in cars, ships, and bridges, anywhere strength and weldability matter. Microalloyed steels with titanium are lighter and tougher. It's proof that a little goes a long way in metallurgy. Next, let's meet another microalloy superstar, niobium. These elements push steel to new heights. Niobium is a microalloy that delivers maximum strength and toughness. It refines grains and forms powerful carbonitrides, locking in steel's structure. Niobium-alloyed steels are used in pipelines, car frames, and massive construction projects. They're strong, tough, and lightweight, perfect for demanding jobs. Niobium lets engineers build safer, more efficient structures. It's the final secret ingredient in modern high-performance steel. With niobium, steel reaches its ultimate potential. Now let's wrap up our elemental journey. From carbon's strength to niobium's superpowers, steel is a symphony of elements. Each ingredient transforms iron into the backbone of our world. Buildings, cars, tools, and more. Next time you see steel, remember the invisible army of atoms making it possible. Material science lets us build bigger, stronger, and smarter. Thanks for joining me on this journey. Drop your questions or ideas in the comments. See you in the next video.